Okay, you were looking at number 12 through 15, so I'm looking at those now. Took me a long time to get back to you, I apologize. All right, number 12. In this problem, I am picking one similar, 5i plus 4j. And when we have that situation, the I is on this axis, the j is on this axis. So the I number is 5, the j number is 4. So this is talking about this point right there. And we are asked in number 12 to find that, this is a vector, and we're asked to find this, and that is the magnitude of the vector, and that's just the distance from the origin. So I'm going to make a right triangle out of the problem. On mine, I go over 5 and up 4. So to find this section, I use Pythagoras. So I get 25 and 16, which adds to 41. 5 squared plus 4 squared equals c squared. So the square root of 25 and 41, 25 and 16 is the square root of 41. So that is which is called the magnitude of the vector, square root of 41. And we also have to figure out what this angle is. We always use tan inverse to do that. So opposite over adjacent, tan inverse of 4 over 5. So let me see what that is. Make sure I'm in degrees for this one. I think I am. I got 38.7. So this problem asks for the angle and the magnitude. So there you go. Hopefully you can match that work to the similar problem. All right, on number 13, we're asked to find domain and range. How about I do the first 3 and let you fly through the last 4? I'll give you a push. All right, the first one, you need to look at the graph to find the domain and the range. In this one, we learned how to do that, but you may just plug it into your calculator, but try to come up with a graph. The square root of x is a graph, one of the basic graphs we learned that goes like that. And -4, hugging it, we'll move it to the right 4 steps. So when we see that, goes over here. And then we can find the domain and range of this graph. So the domain is all the x values, the range is all the y values. So all the x values that will connect to this graph can be found with your eye by saying, will this value for x ever touch the graph? If I go up or down, will I ever touch this graph? I will not. How about that one? This one, this one. So you can see we're not going to touch the graph until we get right here. At that value, x equals 4, and every value after that will be in the domain. So we can write that as x is greater than or equal to 4. And then this next one is the y values, so we're going to look at those. So if I go to the left and right, will I ever touch this graph? I will not. This is not in the range. This isn't, this isn't, this isn't. The first one that is y is 0, and everything after that will, if I go to the left or right, will touch the graph. This graph is getting larger and will touch every y value greater than 0. All right. On the next one, it'd be helpful to remember how we graphed this. We did graph these rational expressions. So I'll show you that real quickly, but you may look at it on your calculator. I factor the bottom. I see that this cancels. So normally we look at these as values which are, these are values where there is an asymptote. But when the same factor is repeated on the top and the bottom, it actually causes a hole at x equals 2. This, and this down here is an asymptote at x equals -2. So this is an asymptote. So we recall this as a slash type of situation. So we have an asymptote here. And if you give yourself a starting point like 10, you'll see that this will start at a small positive number. And when we get at x equals 2, that's where the hole is going to be. And it bends up toward the asymptote. And again, you can get this from your calculator. We did learn to do that, and that was a quick rendition of that. But looking at this graph, can you tell me what is the domain and what is the range? The domain, again, is all values for x. So looking at these values for x, I see that they do connect to the graph. If I go up or down, I will hit the graph, except right here and right here where the hole is. So where the asymptote is, so we say x cannot equal -2 and 2. Fancy way of saying it is x, the domain, equals x, an element of the reals, such that x does not equal -2 or +2. All right, the fancy way for the range is y is an element of the reals, such that. And we look at this graph from the y direction. This will touch the graph, this will touch the graph. There is an asymptote, a horizontal asymptote here. So y cannot equal 0, but you can see it will touch the graph everywhere else except this one spot right there where it is. And it turns out when that value happens when x is 2, so what would y equal? So I put a 2, x equals 2. Now I'm not sure what, yeah, that's true, that's x equals 2. So if I put a 2 here, 2 here, I get y equals 0. So we can ignore that for now. We'll just say that y cannot equal 0. All right. Let's go ahead then and look at this last one that I'm going to do for you. Hope this is helping. When I looked at the graphs for that, really that's a hidden circle. If you square both sides, you get y squared equals 4 minus x squared. Move the x over, and it's just the equation of a circle with radius 2. But again, your calculator could help you find that. I'm sorry, it's only the positive part, so it's half a circle. So if you put that in your calculator, you're going to get a graph like this. So seeing the graph is all you need to do. So the domain is x, an element of the reals, such that what values for x are included in this graph? Can you see that the values for x that will connect to this graph go from -2 to 2, including 2 and -2? And the range will go this way, and it starts meeting the graph at 0 and will end at 2. All right. So I hope that helps you get started on number 13. I'm not sure how long I have blabbed away, so I'm going to go ahead and give you a part 2. So see you at part 2.